Hello everyone and welcome to Server Tribe's webinar. I'm Brenton Ford and I'll be your host for this session. I've worked in SysOps for the greater part of 2 decades. I started my career in SCADA for power distribution utilities, and I was lucky enough to work from the wires out in the remote substations out in the field all the way through to the control centers and building the servers, upgrading the systems, working on the diagrams. So I've been very lucky to have a great and broad range of experience. I got into SysOps Automation when I was working with utilities across Australia and New Zealand, building and upgrading the control systems, the servers and the environments, where we were seeing that a lot of this work was repetitive work. We needed to automate and streamline the packages of work that we were delivering. So we went looking for solutions, and we found that there was nothing really simple enough. So we created our own solution the goal was to be incredibly simple, to cut and paste existing scripts into it, and that it would just work at that basic level. And so I've got a presentation here today for streamlining IT operations with SysOps Automation. And so I'll explain how that improves the efficiency in organizations, and I have a demonstration of Server Tribe's Attune towards the end. So I'll go through our agenda for this session. So I'll start off with an introduction about SysOps and SysOps Automation. I'll then provide the benefits that SysOps Automation delivers to organizations. And I've got a series of use cases that can benefit out of implementing SysOps Automation with. And then I've got several steps for implementing SysOps Automation as best practices of what you can do to get started with SysOps Automation, or if you've already started your journey, where you can jump into that. And then that'll follow with the demonstration of Server Tribe's Attune. I've created an environment with 3 MySQL instances that are operating as a group replication. And I'll show how that was built, and I've got steps that take a backup of that data set and we'll deploy it on a 4th instance as restoring the data. And I'll show how that whole process works. And I'll then do a Q&A at the very end. So if you have questions, please put them into the chat and I'll do my best to answer them. And I'll be happy to dig into the product a bit further if you would like. So I'll go back through the presentation if you want that. So please feel free to ask anything. That would be great. So let's get started. SysOps, which is short for System Operations, refers to the set of practices and processes that are used to manage and operate an organization's IT infrastructure. This can include servers, networks, databases, storage systems, and other IT assets. SysOps Automation is the use of automation tools and techniques to streamline and optimize system operation tasks. Those tasks are typically made up of periodic tasks and aperiodic tasks. So your periodic tasks are repeated on a specified time interval and generally have strict deadlines. They're typically the system backups and monitoring type tasks. Your aperiodic tasks are performed on demand and generally kicked off with an external trigger. These are typically system fixes, restores, upgrades, and integration type tasks. There are several benefits to implementing SysOps Automation in your organization. First and foremost, automation tools can help SysOps professionals to perform tasks more efficiently, accurately, and consistently. Consistency reduces the risk of human error. Myself personally, I find it great that I can practice a process in a test or a development environment before rolling it out into prod. And it's not practicing that I'm performing all the steps, it's practicing that a tool has automated and orchestrated all of those steps. So there's no risk of myself making a typo that I didn't see, unintended, or accidentally implementing a step incorrectly and continuing through. It's all done and captured that the steps were performed, logged, and stored. It leads to faster deployment times, increased uptime, and improved system performance. With all the steps orchestrated, there's no downtime between me moving over to log into another server, another instance, type out the process, however I'm deploying that script or clicking through the UI guide. We can squish the whole process of that window that we need to deploy into a production environment. It's all automated. The computer rolls it out as fast as it possibly can. And additionally, it can help with compliance and security. So as automation can ensure that systems are always up to date and secure. If you've got your processes streamlined for upgrading, you'll be encouraged to upgrade more often. So quite often it's because it takes too long. You delay it, you put things off because you don't have the time for it. But if it's streamlined and automated, you've made the time for it. With automation, you won't be trusting that your processes work. You'll be verifying that your processes work. Your processes are practiced beforehand. Just like I was saying, you're working in your test and dev environments, you're creating your processes, you're running them, you're testing them, you've proven them. So you have the confidence when you move over to prod that they work. Use cases for SysOps automation. You can automate the process of configuring and maintaining servers. This reduces the time and effort required to manage IT infrastructure. Automate the process of building, testing, and deploying software applications, reducing the time and effort required to manage complex software development and deployment workflows. Automate the process of provisioning new servers and other IT resources, reducing the time and effort required to deploy new infrastructure. I think this is fantastic. If you have multiple projects running at once, you've got your teams tripping over each other because they're working in the same environment. If you make it super easy to spin up new environments in their own isolated areas, your project teams are then encouraged to go and they've got their own workspaces that they're not being interfered with. They can confidently develop their work and test it without interference. Automate the process of monitoring IT infrastructure for issues, triggering alerts when problems are detected, and taking remedial action to resolve issues. So ideally, you could create processes that when an issue, it's monitoring for an issue. When that issue arises, it can then trigger the automated process to correct that problem. Like if it's space monitoring, it can then go and truncate logs or anything like that. And automate the process for backing up and recovering data systems, reducing the risk of data loss and downtime in the event of an IT failure. You schedule your backups. You're confident that they're taken the same way every time. And if you've practiced your recovery process and it's in a streamlined automated process, you can be confident that when you go to restore that data, you can do it as fast as possible. So the best practices for implementing SysOps automation. So while SysOps automation can be incredibly beneficial, it's important to approach it strategically. Here are some best practices for implementing SysOps automation in your organization. So start with small, simple tasks and gradually build up to more complex ones. SysOps automation is an incremental improvement process. If you start off trying to implement everything, it's going to take a long time before you start seeing those results. However, if you start with small tasks, it'll cascade and get quicker and quicker along the way. And get buy-in from stakeholders and involve them in the planning and implementation process. So this is great for identifying what are critical processes we should start automating. What's going to help the business the most to get started straight away. Choose the right tools and technologies based on your specific needs and requirements. There's a lot of automation technologies out there, and some may be required for a later step. Some may be what you're looking for right now, but you've got to identify what we should be implementing and how you're going to benefit from it. Implement proper testing and quality control processes to ensure that your automation workflows are working as intended. So of course you don't want automation there that isn't delivering, is creating errors. You've got to continuously maintain it and work on it and test that those processes are working. So you've verified that your processes are always working. And continuously monitor and optimize your workflows to ensure that they remain efficient and effective. And this goes back to the starting small and using those incremental improvements. As you've developed your automation processes, you can continuously work on them, make them better, improve them, find pieces that can be optimized. It's not something that you get to a finish line and you're done. You're always going to be working on this. And as you save more and more time because the process is automated, you'll have more time to work on this. Okay, fantastic. Let's now dig into the demonstration. So I'll get a diagram up to show the network and of what we're building here and how everything's connected. I've deployed 3 LAMP servers in DigitalOcean. Now, a LAMP server is a stack of the Linux operating system, Apache, MySQL, and PHP. So I've just picked this because it's easy to get a Linux OS with MySQL, as this demonstration is going to be using MySQL. I configured each of those nodes for group replication and then configured the firewalls so that the group could talk to each other. Following that, I built a test environment which was just a LAMP server deployed by itself. It's not part of the group replication. Attune was then configured to connect to all 4 servers, perform the configuration, and schedule the backups and deploy the dataset restore onto the test environment. So I'll now jump across and show you that demonstration. I'm performing this demonstration using Server Tribes Attune version 5.1. For those who aren't familiar with Attune, if this is the first time you're looking at it, it's divided into spaces. We have design, plan, run, and the self-service portal. And I'll be going through all of those in this demonstration. In the design space, we have projects, and each project is self-contained, and they contain the blueprints, the steps, the files, and the parameters. A blueprint orchestrates the order of the steps. As we can see, we've got a list of blueprints here that are part of this project, and within those are the steps. In each step, they'll contain the details of which parameters are used for the configuration of that step. So when we go to plan this job, values will be plugged into these parameters. So we'll tell it, all right, we want to use this blueprint to talk to a node with this IP address and use these credentials to log in. And this is for this, as an example, this step will be performing this script. And there's various different types of steps that can be run. In this case, the majority of these I'm connecting to a Linux server, so they're just running just an SSH connection with a bash script. Some of them get quite complex. So this here, I've configured this step to edit a file. So if you're looking at the top here, I've got the script configuring the variables to use within that I want to deploy into this file. I then have this block of code here to actually back up the file I'm going to edit. This way, it's just so I can make this step repeatable. If when I was creating this process, I put an error into that log, I want to be able to fix a script and rerun this log off the same config file. And this is restarting the service. And it's really important that Attune only captures what you would see in the terminal if you were typing out your command. So if you put a command in there that doesn't print a log, Attune will capture that exact log of nothing. So in this case, I restart the service, but I also like to print the status of the service so that when I go back and look through the history of when this job was run, I can see the status immediately after the restart was performed. And same with this script here. I'm deploying MySQL, and I've told it to be verbose and print the logs, which we will see when I go to run these steps. So for this demonstration, I'm actually going to use two blueprints that I have here. So there's the group replication. This single blueprint is going to be run against 3 servers, so 3 times for each individual 3 servers. And then I'll be running this blueprint here once to start up the group replication. It actually this step talks to all of those servers, all 3 servers. So if we go across the plans, I have already created these plans to save a bit of time here. So these are the 3 plans using that configure the MySQL group replication. We have this one for LAMP01, LAMP02, and LAMP03. If we have a look at the inputs, this is where we connect our parameters to values. So I'll just go through a couple of these. So we've got the node that we'll connect to. So this one, I've written it for LAMP3. So this connects to the node LAMP3, and the server instance ID I want to use is 3. Just a simple ID here. I've got a brief description I've put into the parameters. So if we go to values, we can look that up. LAMP03 here, it contains the IP address, the port to use, host name, etc. And that server ID that I was using, it was just a text variable. Very simple to create. Some other values that are used in here. So we've got our replication group, and this is a list of servers to use. So I do have a step in there that will run through this list of servers to perform actions against. For example, so I'll just have a look at the plan for starting the group replication, and that's why we're using it here. That's the list of servers. It'll connect to this node, and there's a step where it runs through all those servers. Actually, I will show you that step because it's an interactive step. So if we go back to design, start MySQL, start up remaining MySQL nodes. So what this step here does, it performs a loop through that list of servers, creates its own SSH connection, and performs a MySQL script. But when it does this SSH connection, it's going to be asking for login. So if we go to details, we can see that I have configured this step to run a script with responses. What that means is when you're using the terminal, if you run a command and there are other responses, such as it asks yes to continue or something like that, such as you get this command here, you can actually submit a response for Attune to feed back into the terminal. This is great for submitting passwords. And so in this case, for this step, running that SSH command, it could be the first time connecting to that server. So if it's the first time, we'd get this message and followed by the password. And on the second attempts, if it doesn't see this message, it doesn't matter, it continues and it'll submit the password. So that's the basics of how an interactive or a Linux script with responses will run in Attune. It makes it incredibly flexible. So that's our plans configured. And if we step across into the run space, we can see that we can see our plans listed here. So we've got our configure to configure the 3 instances. I will kick those off now. So run the first one, run the second one, and run the third instance. So I've got, I'm watching the logs on those 3 servers that I've connected to here through the terminal. You don't necessarily need to watch the logs. I'm just watching them for this demonstration because those logs will be fed back into Attune and captured here. So when we configured the firewalls for port 22 and TCP, this was the result. For OpenSSH, for the MySQL ports that are required, the configuration file that was deployed, and restarting MySQL, that was the status that was printed. And this is captured for all the 3 servers that this was run against. So now we're ready to start the replication group. So I will kick off this job here. So that's all happy, that's started up, and now it's running through connecting to the other 2 nodes in that loop that we had performed. So you can see here that with responses, this was requested and Attune responded with yes. The credentials were requested and Attune responded with the hashed out password. So that's our replication group configured and started up. For the sake of this, I want to put some data into the database, which I've got a snippet that I've created in here. Command S to open up snippets. Here we go. So I want to populate a demo table. So I've got a, no, I want to create the demo database and table first. So I've got this snippet that I'm just going to run. I'll perform that on Lampo too, just for fun. Run that. So it created the demo database. So I'm just changing to use that demo database, and it should have created the demo. Did I just call it table? You have an error. Oh, sorry. Show tables is what I'm looking for. And that's our table. So that table will be empty at the moment. I've got another script here to populate that table. I'll do that. And that's the data we just populated in there. To prove that this replication group is working, you should be able to see that, where am I? data in these other groups now. First off, I will need to select the database. This will work now. Fantastic. And just for fun, prove it over here. So that's the data being replicated across that group. So it's all working. That's fantastic. I'll just leave. So I'm just tailing the error log file. So if we go back to Attune, now the fourth instance for our test environment that was created, there's a job to take a backup in preparation to do the restore of that fourth instance. It's not necessarily a complicated blueprint for this one, so I've just written it in a way. So there's no services running here or anything like that. So in this environment, I'm just locking the tables, performing the dump, unlocking the tables, and then transferring that backed up file over to the other server. So I'm performing this from a node in the replication group, which is configured when I get to the plan. If you're in your organization or wherever you're performing this, you would want to, you might have additional steps in here to, if you're doing it in production, transferring services over to another node so that when you take this back up and lock the tables, it doesn't affect your services and your production environment. So you're able to keep your uptime running while you take your backups. And the restore is a single step here. Let's restore from that file. So in the plan, if I look at the backup, so here for this plan, I'm going to perform the backup on the third instance in the replication group. So that's what I've configured here, the node. And then this is the parameter I have, the backup node, where the backup file is being transferred to. So it is important that when you're creating your blueprints and your parameters that you use great names, and I haven't put any, I should put descriptions in here, and eventually I will, describing what's expected to be created for the value, and perhaps examples generally help. This is the database to be backed up, and that's populated in the script. So if we jump across to, actually, because I've scheduled this, I've turned the scheduler off. I can turn that back on. I've configured this backup to be performed every hour. On the 5 minutes past the hour, I've configured it there. That's enabled, so that will run this plan. You can configure multiple plans to be run in a schedule, and one after the other, and set it up so that if one plan fails, that it won't continue through the other jobs until it's investigated by a system administrator. Because you may have some instances where you want to run through a scheduled list of jobs, but if something fails, you don't want it to go and deploy that failure across your whole environment. You want it to stop there, investigate, and figure it out. So I'll leave that up and running. We won't get to see this kick off in our time here. However, when a job does run from a schedule, you will see the calendar icon there. So that just indicates that this job was run from the scheduler. If there's no icon, it wasn't. It was just run from this panel here, manually kicked off. So I will just perform this by itself. I'll just run this manually so that way we get the backed up file onto the test environment. So here we go. Look through the log. Backup was taken. Unlock the tables, and that file was transferred. Fantastic. Now we'll have a look at the plan I've created for the restore. And what I've done here in the restore, I've told it to enable being run from the self-service portal. So this is the perfect place to put jobs that are run by users who aren't system administrators, who aren't configuring jobs, designing the plans. These are jobs for if you're a test engineer and you just need to be able to restore a database onto your environment when you're ready, when you want to run it. This makes it super easy. So I go, I want to restore this demo database. I can run it from here. We can see that it was performed, and there's a little icon there to say that it was run from the dashboard. And if we have a look over here, so we have that icon here to say that it was run from the self-service portal. And when it is run from the self-service portal or it's run from the scheduler, it will archive those logs. So if we look in history, we can then go back in time and see what happened when they were run previously. Okay, so if we jump across to the terminal now, let's go to that fourth instance. Reconnect. I'll have to transfer to that database. So we're using that one now. And if I go select, there we go. So that's our data restored, 500 rows of what we put in there. So these projects that I've created here, so the backup and recovery, the creating of the replication groups. Now there's a couple of other blueprints here. This is for creating where you've got a master and follower. So you've got a source, server, and then replication servers. So I've created blueprints to configure those as well. If you were interested in not designing it from scratch, but actually starting with this work, these projects have been uploaded to GitHub. So you can clone them for yourself from GitHub, make changes, improve them, and then share those changes with everyone else, push them back up to GitHub if you want to. And that is, here's an example. So on GitHub, I can share these links with you after this webinar. So deploy and set up MySQL on Windows, that's a different one. So if I jump back over here, look at the repositories, MySQL replication. So that's the setting up the replication group. So the project is stored in here. There's instructions on how to clone. So you can do that for yourself. Okay, so we're now ready for the Q&A. So if you've got questions, please submit them through the chat. And if anyone wants, I can have a look at continue through other steps of the product if that's of interest. I'll go back to sharing my screen. Definitely. Been asked about can this platform used to be shared data between 3 or 4 apps. So if they can be, like if the data can be scripted, it'll perform anything that you can write with a script. So you could figure a job to take data down. If there's a certain frequency that you want this data sync to be performed, that can be deployed into a scheduler. If the data sync is to be triggered on demand, that's where that running a job from the self-service portal can be configured and set up to perform. So in that example that I provided there was that we were taking a database dump from our MySQL server, passing that data across into another environment, and then restoring that data onto another server. But it could be written in a way that instead of running 4 jobs to deploy against 4 other apps, you could write that deployment to 4 other apps is in one single job. So yes, that can be orchestrated in Attune. So I guess I can go into greater detail on that. With how we work so power distribution utilities is my background, where we build their production environment. So we'll practice in building their dev environment, and then we'll shift into a pre-production environment, practice the process for cutting over into production, then we'll shift into their production and perform that. But when they're using their test and development environments, quite often they'll want the latest data from their production environment. So we typically schedule nightly backups. They have a multi-master replication system, so we'll schedule a nightly backup to take down one server out of that replication system, take a data set backup, and then bring that server back into replication. And then that data set is then stored in the Attune instance that's located in their test and dev environments. And then that's available on demand, so that their test engineers then, when they're ready, if they do a destructive task in their test environment, they want to restore data, they can run it then and there. As a use case from one of our clients, before Attune, it was taking them a system administrator's time for 3.5 hours to perform that restore into their test environment, taking down services, restoring the data, bringing up services. When we orchestrated that whole process into Attune, it was then down to 15 minutes, and it could be run from that dashboard. So I've got another question. How versatile is Attune? We have some systems at present that make part of the process, such as Ansible for configuration management. Where would Attune fit in? So some clients that are using Attune, they already have Puppet and they have Ansible. That's where in the presentation I was trying to talk about the technology you need to select needs to be based on what specifically you're wanting to deliver. So for example, Ansible's fantastic for configuration management, and then Puppet is brilliant for the management of packages. And so we have Attune. It just deploys scripts, so it's not just specific to MySQL. It works with anything you can run a script. So it'll connect to Windows servers with WinRM or Linux servers with SSH. And we've scheduled orchestrated processes from connecting to servers from bare metal or a virtual host. It'll connect to the virtual host to spin up a virtual machine, and then go through the entire process from start to finish. Deploy the operating system, install that. It'll then connect. If you've got Ansible configuration management, it can trigger Ansible to say this server's ready to join your services. It'll then go through. It can connect to Active Directory, tell Active Directory that this server's ready to join. Same for down the line once it gets to the Puppet point, connect Puppet. And so it does all that in between work. It can also do that, but it depends on what level you're at to. If you have the infrastructure to configure Ansible for configuration management, if that's justifiable, that's fantastic. But Attune is like the glue that can connect everything together. It can run those really customizable scripts that are unique to your organization. Yeah, so it doesn't just work with MySQL. I used that in this example because it was super easy to spin up something really quickly. We haven't, in regards to restoring data, so we have in cases where we've wanted to accelerate if it's enormous amounts of data that take a significant amount of time to take a backup of and restore. We have had cases where we've broken that data up into specific tables and tried to max out the CPU usage, run multiple data set dumps of just segments of the database, monitor that. We will practice it, monitor the CPU usage and see if we can break it up some more just to accelerate the speed to take a backup, and then it's restored in the same, you mimic that same process to restore it, and you can maximize the time it takes, so you minimize the outage between backup to restore. But it's something that you get to practice and you've got the process automated there. Training for Attune. So Attune doesn't require a lot of training. So the goal was to create Attune that had to kind of be able to be used by system administrators. So the existing knowledge they have, they should be able to pump that into Attune and go from there. So it's just about learning, I guess, the process of Attune, how you have your design, break up your steps, and then move across. The steps that are written here, so for this step here, it's just this is a Bash interpreter, but it would also use Python and Perl. If I was to add a Windows scripted step, it has its interpreters there, and system administrators are likely to already have these scripts saved in a text file, and they can just cut and paste those into Attune. Now, ideally, we can break them. Sometimes a saved script may be 2,000 lines long. It's ideal if we can break those into smaller steps, so that way, if there's an error when we're running a job, we can debug that error and then continue it on. If the script is too big and you have an error, sometimes it's not a case of just fixing the error. You may have to clear out half of what the script has done and go back to the beginning again. And so that's not what Attune is. Attune is SysOps Automation. It's able to fix that step and continue on. So there's no unique languages in Attune. It uses the popular scripting languages that your system administrators already know. Thank you, Shannon. If you want any more information, I can just send an email through or anything like that, and I'll be happy to send anything through to you, or I can provide another demonstration if you want something specific as well. I'm happy to do that. The split view, that was another application I was using just to demonstrate what was on the servers. So this is Termius. Which it is in our roadmap. We would love to get something like this directly into Attune. And yeah, so these blueprints are, the blueprints are uploaded to GitHub as part of a project. So it's the projects that are stored into GitHub. So Attune, one of the largest differences between Attune v4 and v5 is version control, and we've created a projects which contains, this way we're able to divide up blueprints, files, and parameters, so that's not a giant pile. We can actually divide everything up. You can have projects while you're working on something different. So here, this is a private search engine blueprint that I created, and that way you can commit any changes that you've made so that you've got your version control, and you can also then push them up to a remote, whether it be, so this one here, I've got it into my own remote, my own GitHub account. And then from in GitHub, you can then do a push into Attune's. If you've got changes you want to improve on an Attune GitHub blueprint, that would be fantastic. You can put that up there, which I think I can go back to that page here. So these here, if you were to clone a project, so that would just be grabbing the URL, going back to Attune, finding a project and entering the URL in here. So another way Attune manages files, so because GitHub, Git repositories don't store large files, they're for storing code and scripting changes, ideally. So the smaller scripted configuration files can be stored in the Git repository, but the large files like 4 GB ISO, if you configure the files to have the URL where it can be downloaded from, you can tell Attune to download that file in the background. I don't have any in this example. There should be one in here. So in this case, I don't have a URI, so Attune didn't download that file. Let's put the little warning there to tell me that this file is missing. However, I did have the URI for this file, so Attune has downloaded that file in the background. That's provided your Attune instance has an internet connection, or if that URI could also be to a NAS in your own network if need be. Okay, I will finish this up here. So yeah, feel free to reach out to me on LinkedIn, or there is also a Discord channel if you want to reach out on there. Okay, thanks everyone for attending. I'll finish this up. See you next time.